In this video, we're going to solve an equation with two or more radicals. So usually what this looks like is an equation. Remember, equation means two expressions separated by an equals, not an approximately. And in this case, we're going to see two or more radicals. So square roots, cube roots. I think all the examples I have on this page are square roots, but these could just as easily be cube roots too. In these, since there's two or more, we just need to focus on isolating one of the radicals. So just worry about one side of the equation and getting a square root or cube root alone on one side of the equation. The other side, we just have to sort of leave it and we'll hope for the best. And we'll see that in action in the three examples here. Use the principle of powers. That means raise both sides to some exponent. Sides to the same exponent in order to get rid of the radical. So if it's a square root, we square both sides. If it's a cube root, we cube both sides. After we do that, we're going to simplify everything and combine like terms. And if there's still a radical after we combine like terms and simplify, then we do this again. We get the radical alone and raise both sides to a power. Always check. Right, so after we solve, meaning get the variable alone, so solve always means get the variable alone, that's our goal. Then we're going to check that solution because we could get extraneous solutions in these problems. All right, let's try one. So this one has more than one radical, but I already have one isolated. Remember, we're just trying to get one of the square roots alone on one side. So even if there were other stuff on the right side, this is a fine way to start. And we're going to square both sides. And by both sides, we mean everything on the left and everything on the right. But in this one, it actually works out really nicely because the squaring undoes this square root and this square root. So I just end up with 2t minus 7 equals 3t minus 12. Because both square roots get undone by the squaring. And then it's just a normal kind of equation to solve. I need to get t by itself. I'm going to subtract 2t from both sides. So that's going to be negative 7 equals t minus 12. And then add 12 to both sides. So that looks like t equals 5, or 5 equals t. Before I can write this in curly brackets, though, I have to check. This might not really be the solution, even though I did the steps right. So we're going to use the original equation and just plug in 5. 2 times 5 minus 7 would give us the square root of 3. It's 10 minus 7. We will know, is that equal to the square root of 3 times 5 minus 12? And 15 minus 12 is also the square root of 3. So I don't need to use a calculator on that. You certainly could for what's inside there. There's no reason to get a decimal. Square root of 3 just is equal to square root of 3. So our solution, when we write in curly brackets, is 5. Great. So that's as easy as it gets when you have more than one radical in an equation. More often, what we'll see is that there's a third term. So the next two examples have this third term that's going to make it a bit more complicated. But first step is still the same. Isolate one of the radicals. So I have to get one of these square roots by itself. So I'm just going to add the square root of x minus 2. Square root of x minus 2. So then what I have, after I add that, is the square root of x plus 3 equals 1 plus the square root of x minus 2. All right, I got a radical alone, so to undo a square root, I need to square it. But it's squaring both sides. And unfortunately, squaring, or any exponent, does not distribute over addition. We can't just say this is 1 squared and then that square root squared. That would be a whole lot easier, but it's always going to be wrong. So instead, what we have to do is write it as 1 plus the square root of x minus 2 times 1 plus the square root of x minus 2. That's really what squaring means. And I'm not going to write it. I still want there to be two sides of my equals here for the equation. But we need to use FOIL. That's how to square a binomial, meaning anything that has two terms when we're squaring it. So we actually have to write it out. Let's FOIL. 1 times 1 is 1. 1 times the square root of x minus 2 is the square root of x minus 2. Square root of x minus 2 times 1. The square root of x minus 2. And then square root of x minus 2 times square root of x minus 2. When we multiply a number by itself, that's the same as squaring it. So that actually undoes the square root. Right? Just like if you took the square root of 2 times the square root of 2, you'd get the square root of 4, which is 2. Multiplying any radical by itself undoes the square root. So at least that helps us a little bit. So now I'm going to go back down here and see what we got now that we've FOILed out the right side of the equation. The left side's easy. Squaring undoes the square root. X plus 3. The right side is the result of this FOIL. So we have 1 plus, and I'm going to combine these like terms because we have 2 of the square roots. 2 square root of x minus 2, and then plus x minus 2. All right, this is a good time to take a breath, right? That was messy, and we're not even done yet, unfortunately. So now if you go back up to the top where it had those steps, it says if a radical remains, if there's still a square root there, we have to repeat this process. We need to get the square root alone and then square both sides. First thing I'm going to do, to get the square root alone, I'm going to subtract x from both sides, and I'm going to combine like terms. Meaning I have a plus 1, minus 2, so that would be minus 1. This plus this 2 in front of the square root, this is a multiplication. So that is not a like term. This is one unit. And you might even want to mark it like that. This is one thing. So I can't combine it as a like term with the other numbers there. Well, the nice thing is, though, that the x's cancel on both sides. So that's actually not so bad. And I get 3 equals 2 times the square root of x minus 2 and then minus 1. Right, because the plus 1 minus 2 makes a minus 1. All right, we're almost there. It's looking nicer. At least we're making progress. So now I get 4 equals 2 times the square root of x minus 2. This might be a good time to remind us of our goal. Get the square root alone. And I'm almost there. What I have to do next is divide both sides by 2. So divide by 2, divide by 2. And so what I get, I'm just going to go over here, is 2 equals the square root of x minus 2. And then I can square both sides to get rid of the square root. 4 equals x minus 2, and then add 2 to both sides, which would be x equals 6. All right, are we done? Unfortunately not. But checking hopefully isn't too difficult because it is just plugging in. So let's see, I'm just going to check right here. Hopefully I can squeeze it in. So I take the original equation and I'm plugging in x equals 6. So I get the square root of 6 plus 3 minus the square root of 6 minus 2. And I want to know, does that equal 1? Square root of 6 plus 3 is the square root of 9. 6 minus 2 is 4. Square root of 9 is 3. Square root of 4 is 2. Hey, it actually equals 1. It checks out. So our solution set is 6. All right, so that's as hard as these get, right? Is this idea of having more than one radical and a third term in there as well. Let's try another example because clearly like that wasn't easy. So we'll try one more and hopefully that'll be enough so that we can try more of these in class. All right, last one. So this is another one where there's two radicals and a third term, which makes things a little harder. So I need to get one of the square roots alone. Now it doesn't really matter which one, but I'd rather get rid of the complicated square root first. So I'm going to subtract the square root of m from both sides. So what that gives me is the square root of m plus 2 equals 9 minus the square root of m. To get rid of the square root, I need to square both sides. But remember, it's the entire side. So when there's a third term, we have to use FOIL on this. So I need to write out 9 minus square root of m times 9 minus square root of m. And then see what we get. So what I get is 81 minus 9 square root of m minus 9 square root of m, and then two negatives make a positive. So negative and negative make a positive, and the square roots undo each other, so we just end up with plus m. Alright, so that was the FOIL part. Now let's go back to our equation. We can combine these like terms, put it all together, and see, hopefully it simplifies. So on the left side, the squaring undoes the square root. I just get m plus 2. On the right side, that's when I get this mess. So 81, if I have minus 9 of a square root and then minus another 9 of the same square root, that's minus 18 of those square roots, and then plus m. Alright, this one actually looks a little nicer than the previous one, thank goodness. So I'm going to subtract m from both sides, which is great because that cancels the m on both sides of the equation. Remember our goal, get the square root alone. So right now I have 2 equals 81 minus 18 square root of m. So I need to subtract 81 from both sides. And that gives me 79 negative 79 equals negative 18 square root of m. On the previous video, we talked about how if a square root equals a negative, that was no solution. But this one actually does have a solution because we need to divide by negative 18 before thinking that we've solved for the square root. So we have to get the square root completely by itself before we can say, oh, the square root equals a negative or not. Now, here's the ugly part of this. 79 over 18 does not simplify. It is just an ugly fraction. You could get a decimal approximation, but why bother? Fractions are lovely. Let's just leave it like that. And we need to square both sides. So when I do that, separate these, I get that m equals 79 squared is 6,241, 18 squared is 324, and at that point I did use a calculator and I found that that's close to 19.262. So that's the exact values, that ugly fraction. The approximation is from the calculator. Even though this is an ugly answer, we still need to check it because anytime you square both sides of an equation, you could get an extraneous solution, meaning one that does not check. So let's try it. I'm going to use the calculator, so I'm using the decimal, and I'm just plugging into the original equation. So square root of 19.262 plus 2 plus the square root of 19.262. You put that in the calculator, and it should be a number that's close to 9. I don't want you to trust me on that. I want you to try it on your own calculator, but yes, it does check out that even though this is really ugly, the solution does check out. It equals 9.